All right, this is a brief lesson to end our learning about nomenclature, where we just have a couple loose ends that we need to talk about in case you come across these compounds. You will know how to name them, or if you come across the name, you'll be able to determine the formula. So the first type of compound that I want to look at is called a peroxide. So a peroxide, a very common peroxide is hydrogen peroxide. This is a common household substance. It's often used in first aid for cleaning, cuts, etc. And it is hydrogen peroxide with the formula H2O2 is basically a water molecule with an extra oxygen. So extra oxygen is basically the definition of a peroxide. We can recognize the prefix per, so PER, to indicate that we have extra oxygens bonded to a polyatomic ion. So a peroxide is when you have a compound that contains an extra oxygen. And when we name them, we just use the prefix per to indicate an extra oxygen atom has been added. So we're going to look at an example. So if we were to determine the formula of barium and oxygen when they bond together in an ionic compound, they both have an ionic charge of 2. Barium is 2 plus and oxygen is 2 minus. Just like you can see right here, when I crisscross them down, we get Ba2O2. And then we know we reduce that to become BaO, barium oxide. Now, if we end up with, or if we come across barium bonded to 2 oxygens, so barium oxide with an extra oxygen, we now name that compound barium peroxide because it has an extra oxygen bonded to it. Let's look at another example, but first just hit pause and get this copied down. All right, another example, lithium LiO2. So if we wanted to name this, what we would do is we would do a reverse crisscross. So by doing a reverse crisscross, all right, if we do a reverse crisscross and we cross our charges up, we get lithium it looks like that 2 crosses up to give lithium a charge of 2 plus, and an invisible 1 gives oxygen the charge of 2 negative. The problem is that lithium does not have an ionic charge of 2. It has an ionic charge of 1. So this is not the correct ionic charge. So we know that lithium and oxygen, or oxygen should have an ionic charge of 2 minus. So this should be a 2 minus, and this should be a 1 plus. So the fact that lithium oxide has the formula Li2O, lithium oxide is Li2O, and we have a formula LiO2, we have an extra oxygen. So therefore, we know that we need to name this lithium peroxide. Okay. Now, this can be really confusing to determine if you have a peroxide or not. But in all honesty, the only common peroxide that we're probably going to come across is hydrogen peroxide, H2O2, because it's just the most common and the peroxide that I'm going to expect that you know the name and formula for. All right, the second odds and end we need to look at are substances called hydrates. Now, a hydrate is when you have a compound physically bonded to a water molecule. So a common hydrate is when copper sulfate is bonded to 5 hydrogen molecules. Now, we can get into the fact that they're not physically bonded, they're just trapping the water molecules in the crystal. But for our purpose, we're just going to say that they're attached to the ionic salt, the ionic compound. So what we do when we name these compounds is we name the compound name remains the same. So if we were to name our hydrate CuSO4.5H2O, we would still name this copper 2 sulfate. And then we add the word hydrate with a prefix to indicate the number of water molecules attached. The prefixes we use are the same that are used for molecular compounds. So this would be pentahydrate. And that dot that's highlighted in yellow, that means bonded. So our example right here, we still name our ionic compound the same. So in pink, copper 2 sulfate. We use a prefix to indicate that there's 5. So 5 is penta. And we use the word hydrate to indicate water. So hydrate's name is copper 2 sulfate pentahydrate. Okay, we have a couple more here. Another example, this time it's a magnesium sulfate bonded to 7 waters. So this is magnesium sulfate heptahydrate. Okay, so that is the end of looking at peroxides and hydrates. And I just have one more thing I want to show you. So before I do that, hit pause and make sure you have this copied. Okay, the last thing I want to show you is when we have a acid ion, basically. So I want you to take a look at your periodic table and come into the table of complex ions. And when I scroll in, mine is not the clearest, but I'm hoping that we can still see. Now, we know that we can have polyatomic ions that do not, we know we have polyatomic ions that carry ionic charges that are greater than 1. So for example, if we look, we can have a sulfate, SO4, 3 negative right here, or 2 negative right here. Now our sulfate ion can bond to, if it bonds to 2 hydrogens, it becomes an acid, sulfuric acid. But because it has an ionic charge of 2 minus, it can bond with a single hydrogen and still carry an ionic charge. And that's what's happened right here. It's bonded to 1 hydrogen. And so now it has the formula HSO4 minus. It's not H2SO4 because that is when it's an acid and it does not have an overall ionic charge. If it bonds with a single hydrogen, it still has a bit of a charge because it had a 2 minus charge. Bonding it to the hydrogen gives it a 1 minus charge. Now this is still an ion. It's an acid ion. And it can bond with a metal to form an ionic compound. So when you see this, you just have to treat it like any other normal polyatomic ion. But we can't call it sulfate. We can't call it sulfuric acid. But instead, you can name it, it's named hydrogen sulfate or bisulfate. The bisulfate is a completely separate option. The name is not hydrogen sulfate bisulfate. The name is hydrogen sulfate, or it is also be called a bisulfate. Sulfate's not the only one that does this. Phosphorus does it too. And if we look at phosphate is PO4 3 minus. So it can bond with 1 hydrogen and become HPO4 2, or minus, or it can bond with 2 hydrogens and become H2PO4 with an ionic charge of 1 negative. Both of these have a name, hydrogen phosphate, and then if it bonds to 2 hydrogens, it has the name dihydrogen phosphate. Now, these are not the only polyatomics in this table that we have not talked about. So basically, when it comes to our nomenclature, if the formula is in this table of complex ions, it's essentially fair game for you to be able to use in a name. They're all ions. They're all a polyatomic. They're not all of our eights. But there are others in here that we haven't talked about, like, for instance, we haven't talked about chromate or dichromate. Those are common polyatomics that you're going to come across in your nomenclature. And because it's in this table of complex ions, you should be able to determine formulas and name compounds with them accurately. All right, this is all for the tail end of ionic compound nomenclature. You may still have to look at molecular compounds at this point, but then that is the end of our new nomenclature lessons. The key to the nomenclature is to continue to practice. Do a lot of practice and get help when you are stuck. Okay, that's it for this nomenclature lesson, and I will see you again.